So the next question that we are going to do is convert a sorted array into a balanced binary search tree. So let's see how we can do that. Okay. So let's say we have a sorted array. So 1, 2, 3, 4, 5, 6, 7. I think 7 is enough. So we'll have an array of size 7. We want to create a binary search tree. If we use our insert method and it is sorted, then what will happen is first nothing is there, so 1 will actually be created. Then 2 comes, 2 will be there. Then 3 comes, so 3 will be there. And then 4, and 5, and then 6, and then 7. This is probably not a good structure because like it now essentially this becomes a straight like a linked list kind of a structure, which is not a good thing. So what we are going to do is we are not going to do this, and we are going to create it as a balanced binary search tree. So how do we do that? Okay, so what we'll do is we know that this is sorted, and so what we'll do is we'll actually take the first one, which is the start, and start will point over here and end will point over here. So start is at 0, end is at 6. So we'll find the middle of that, which is 4. So we'll actually create node 4. Then we'll call the same function, and recursively we'll call it between 1, 2, and 3. So mid -1, so start to mid -1, which is 1, 2, 3. So the middle of that part is 2, so 2 will be created. Then 2 will recursively call the thing on 1, and 1 node will be created. After that, it will go back, since the recursion will end, it will go back to 2. Then we'll call for 3, so 3 will be created. Then for 4, the recursion is done for the entire left side, so we'll go on the right side. The middle of this side is 6, so we'll create a node 6. 6 will recursively call on 5, so 5 node will be created. And then 6 will call recursively on 7, so 7 node will be created. So this is the balanced binary search tree. So let's actually see how we can write the code for this one. Okay. So we will go over here. And what we'll do is, let's come over here. We will actually comment all this. And what we'll do is we'll pass in an integer array, and that will assign whatever tree node that we create, we'll assign it to the root, right? So we'll be here, so we'll say public, this will be void, create balanced BST from sorted array. Okay, and the array that we are passing is an integer array. Okay, so do that. So first thing we'll check is if ARR is equal to null, or ARR.length is equal to 0, we just return. Okay, or we'll say the root is null. Otherwise, we'll say root will be equal to, we'll pass this, and we'll pass an integer array, and we'll pass integer start, which is 0, and end, which is ARR.length -1. Okay, so now we need to create this function, and this will return a node, and this is taking an integer array, comma integer start, comma integer end. Okay, so that is wonderful. Okay, so first thing we'll do is we'll check for the error condition. So we'll base condition, which is if the start is greater than end. If the start actually becomes greater than end, we return null. Okay, otherwise we need to find a middle part. So middle part is equal to start plus end divided by 2. So we get the middle, and then what we'll do is we'll create a node is equal to, the node will be equal to new node, and that node will take ARR of mid. Okay, so that's taking ARR of mid, and this node's left will be equal to, we'll call this function again, and with the array, and the start will be start and end will be mid minus 1, because we have already taken mid. So we do that, and node dot right will be equal to this, and we'll pass the array, and start over here would be mid plus 1, and end would be end. Okay, and we do all of that, and then after that we return the node. Okay, so that is good. By the way, this is pre-order traversal, because we are doing something over here, and then we are going to left, and then we are going to right, and then we are returning over here. Okay, so that is wonderful. So first we pass 1 2 3 4 5 6 7. The middle node is start is not equal to this, so it will come over here. Middle node will be 4. We create a middle node 4 over here, and force left would be, this will keep calling the recursive on this side, and then it will keep calling the recursive on the other side, and then once everything is done, 4 node will have nodes on the left, nodes on the right, and we return the node. And that is what this thing happens. So we'll come over here. We will actually create an integer array of we create an integer array, and then we say BST dot create balance tree from this, and we are passing the ARR. Next, what we'll do is we'll do BST dot level order. This should present our tree. Okay, so I run the main, and it is presenting 4, which is the top one, and then 2 and 6, and then 1 3 5 and 7, which is correct. So we have our tree which is there. Okay.